Good afternoon, children.
Good afternoon.
Good afternoon. I've shared my screen, children. Is it visible?
Yes,
Very good. Yeah, children. So in this question, you can see the figure given there, and we'll have to prove that 1 by x plus 1 by y is equal to 1 by z. For this, let's take up the triangles. Okay, so before that, we don't see parallel lines here, but we can definitely prove that some lines are parallel to one another. So go down to 9th standard, recall this theorem which says that two or more lines perpendicular to the same line are parallel to one another. Two or more lines perpendicular to the same line. Perpendicular to the same line are parallel to one another. Are parallel to one another. So here you can see AB, CD, and EF. So we see these three segments A, B, C, D, and E, F all perpendicular to the same line BF. So by this property or by this theorem, the three line segments are parallel to one another. AB is parallel to CD is parallel to EF. Two or more lines or line segments, okay? So two or more lines perpendicular to the same line are parallel to one another. So here we have AB, CD, and EF are perpendicular to BF. Therefore, AB is parallel to CD is parallel to EF. Okay. Now, we'll have to consider, like two sets of triangles. So the first set here, in this triangle ABF, we also have a triangle CDF. All right, in this triangle ABF, we also have this triangle CDF. Right, let's consider these two triangles. In triangle CDF and triangle ABF. So this angle is common. Angle CFD is equal to angle AFB. CFD and AFB, common angle. That's the angle common to both the triangles. And then angle CDF is equal to angle ABF, 90 degrees. CDF in the small triangle CDF, in the big triangle ABF, each equal to 90 degrees. Therefore, these two triangles are similar by the AA similarity criterion. Therefore, triangle CDF similar to triangle ABF by the AA similarity criterion. So triangles are similar. So let's write the ratio of the corresponding sides. So we have CD by AB equal to DF by BF equal to CF by AF. Okay, so now what is CD given here? Z by AB X equals DF. Okay, so since we don't have any variable for the DF, children, we'll just name it. Okay, we'll just call DF any letter M, N, Okay, let me call it A. And BF, is it marked BF? No. Okay, so that means we'll have to, give a variable for BD also. So we'll call BD as B. We'll call this one as B. CD is X. CD is Z. That's marked in the figure. AB is X, marked in the figure. DF is not marked. So let's take a variable. Let's make it uniform. We have unknowns X, Y, Z in the figure. So let's mark off the other line segments also, whatever is needed in this proportion. So DF, we have called it A. BF is A plus B, as you can see, is A plus B, children. Is A plus B is equal to CF. What is CF? Oh, again, it's not marked. And AF, so not marked. We'll just come back to this if we need it. We'll come back. If we need, we'll mark it as, whatever MN or any other two variables, and we'll come back to this. We'll just stop here. So we've just taken these two ratios. We've just taken these two ratios. We'll call this result 1. Now, take this triangle. Take these two triangles. In this triangle, we have this big triangle BFE, and then we have the other triangle BDC. BFE, BDC. BFE, BDC. Okay. So in triangle BDC, the small one, and triangle BFE, the whole thing, the big triangle, BFE. I proved the lines are parallel to use BPT, and now, okay, so it's okay. So I think we don't need this. We don't need parallel lines here because we already have 90 degrees. Anyways, this is just a recall from 9th standard for you. Let's take it like that. Maybe this result we don't need in this proof, because to prove that the triangle is similar, we have a common angle and then 90 degrees. So maybe we don't need to prove that these lines are parallel. So in triangle BDC and BFE, children. So the common angle is CBD. CBD equal to angle EBF. EBF. That's the common angle. C in the small triangle CBD. In the big triangle EBF. Common angle. And then 90 degrees. In the small triangle, angle CDB or BDC. BDC is 90. In the big triangle, BFE is 90, is equal to 90 given. Therefore, triangle BDC is similar to triangle BFE. AA similarity criterion. Proportion BD by BF equals DC by FE equals BC by BE. In similar triangles, reason for this, in similar triangles, corresponding sides are proportional. In similar triangles, corresponding sides are proportional. Now BD is B by BF, A plus B equals BC, DCZ by FEY. Now the thing is, children, we have a proportion in 1 and 2. Now to compare these two, you should have something in common, and there is this A by A plus B and B by A plus B. We can make use of this. We just need something a common or similar or some connectivity between the two proportions. We have a proportion in 1, we have a different proportion in 2, but there is something with which we can connect the proportions in 1 and 2. We'll see how we can connect. So we'll not make use of this third ratio in both the proportions here and here. We'll not make use of the third one. And one more thing is, so how do you identify which to take and which to, ignore? So you can, in this figure, you can see that BF is common to both the sets of triangles. This BF, where we have A and B, that line segment BF. See, when we took up let me talk with the second triangle. See, when you took up this triangle and the smaller triangle inside this, it has the side BF. And the first one, the first big triangle which we took, this one also has that side BF. So first we proved that FDC, this triangle FDC is similar to FBA, right? So there also you can see the big triangle has the side BF. So BF is a side common to both the sets of triangles. So that is enough. That's how, so that side is enough to link the two ratios, the two proportions. Now the side which we have ignored is BE, and the sides which we have ignored are B and FA. They're not common. They're meaning this side BE is of one triangle, the side FA is of the other triangle. We'll ignore that. Meaning we'll ignore the ratio that comes on those sides. We are ignoring the ratios that come on FA and BE. We are taking BF because we are making use of the line segment BF because BF is common to both the sets of triangles. So that way, in both the proportions, you will have a ratio from this side BF. So with the help of that, you can connect the two proportions. Okay. So now look at the result, children. We'll have to prove that 1 by x plus 1 by y is equal to 1 by z. Now here we have some results in 1 and 2. All right. So now what we'll do, we'll write them one below the other. Z by x is equal to a by a plus b, and z by y is equal to b by a plus b. Just write the relevant things one below the other. This is 1. This is 1. This is 2. Just write the relevant things one below the other. Z by x is equal to a by a plus b. Z by y is equal to b by a plus b. That's what we have in the two results. Now add these two results. 1 plus 2. 1 plus 2 gives. 1 plus 2 gives. What do you get? Z by x plus z by y. Z by x plus z by y is equal to a by a plus b plus b by a plus b. A by a plus b plus b by a plus b. So we have z is common. Z common, so we can take it out, and 1 by x plus 1 by y is equal to common denominator a plus b. So a plus b in the numerator. So z into 1 by x plus 1 by y is equal to 1. Is equal to 1. Because a plus b gets cancelled. So now taking z to the other side, because that's how the result is. 1 by x plus 1 by y is equal to 1 by z. All right, 1 by x plus 1 by y is equal to 1 by z. So we have 1 by x plus 1 by y here. On transposing z, on the other side we have 1 by z. So like this, we have proved the first result. Now the second one, z is equal to xy by x plus y. Okay. Z is equal to xy by x plus y. All right. So we have to go back to this one. We'll have to continue. Like you can mark off this as 1. You can just not 1. We'll mark this as 3 using 3. Okay. So using 3. Using 3, we get z into 1 by x plus 1 by y is equal to 1. Xy is the common denominator. So we have y plus x is equal to 1, which means z into x plus y by xy is equal to 1. Sorry. Yeah, is equal to 1. What's the result? Z is equal to, okay. So z is equal to, when this one goes to the other side, children, when this fraction goes to the other side, it becomes its reciprocal. We have z into, so like if you have 4 into, okay, not 4 into, supposing we have a into. Okay, so we have a into 4 by 5 is equal to 1. So a is equal to 5 by 4. A is equal to 5 by 4. In the same way, z into x plus y by xy is equal to 1. So z is equal to, this fraction becomes its reciprocal on the other side. Xy by x plus 1. This is the second result. Xy by x plus 1. Yeah, children. So I told you that this one is not needed. This one is not needed. So take up this triangle ABF and the triangle inside that CDF. Show that these two triangles are similar and write the proportion. There is in two similar triangles, corresponding sides are proportional. So write that proportion. Then take up this big triangle, and the triangle inside that. That is, take up the triangle BFE and BDC. Common angle 90 degrees. The two triangles are similar. And write the ratio of the corresponding sides. Now, after writing the ratio of the corresponding sides, fill in the variable which is marked against the line segments. So CD is given to be Z. I'm here. So CD is given to be Z. AB is given to be X. Then DF. Now see, another decision you had to make is, now we have two ratios here, no? Which one to ignore? So you should realize that here in the two triangles, BF is the common side. So we will take up the ratios that come on the line segment BF. We'll ignore the ratios that come on that other side, third side. So the ratios that come on the third side are CF and AF. CF and AF, see the figure, CF and AF. The ratio CF by AF is of the side AF. Ignore that. So ignore this one. Take up the ratio that comes on the common side. The common side is BF. On that we have a ratio DF by BF. DF by BF. So take up that. Go ahead with that. Ignore this one. Yeah, and further, DF and BD were not marked, so we call them A and B respectively. So like that, we get the first result. In the same way, write the second result. Now add these two proportions. Write them one below the other. So write them as Z by X is equal to A by A plus B and Z by Y is equal to B by A plus B. Now upon adding, you get so this one. On the left hand side, take out Z common. Right hand side, common denominator A plus B. So that becomes 1. RHS becomes 1. And to get the first result, 1 by x plus 1 by y is equal to 1 by z. Simply because we already have 1 by x plus 1 by y in the bracket. We already have 1 by x plus 1 by y in the bracket. So we just need to get 1 by z. So transpose z. So that way we get 1 by x plus 1 by y is equal to 1 by z. Now, so in this working, I told you mark the step as 3 because we need to continue with this one in a different way to get the second result. We need to continue with this step in a different way. This step, when you continue like this, you get the first result. The same step should be continued in a different way to get the second result. Yeah. So just say using 3, we get, write out that equation and take up the LCM in the bracket xy. So you get y plus x in the numerator is equal to 1. Yeah, I think then it all follows. This fraction becomes its reciprocal when it goes to the other side. So z is equal to xy by x plus 1. Yeah, take a screenshot, children. Well, 1 minute. Let me just erase this. Just a second. Yeah, children. Yeah, please take a screenshot. I think you need to take it once again. So the common side is BF, right? So we'll write this, but we'll not use this. And on BF, we have the ratio here, BD and BF, right? And then DC, yeah. So we'll not go ahead with this one. Yeah. BC by BE. Here BC by BE is the ratio on BE on this side. We are crossing out the ratios that come on this side and this side. We are crossing out the ratios that come on this side and this side.
Taken, ma'am.
Yeah. Done, children?
Yes,
Taken, ma'am.
Yeah. We'll take up a similar question. Sorry, I think it's on the same file. Just a second. Oh, yeah, it's here. Yeah. Yeah, it's a similar question. So here in the figure, if AB is parallel to CD is parallel to EF, then find X and Y. AB parallel to CD, parallel to EF. Then find X and Y. So X is this line segment CD and Y is this line segment DE. X is CD and Y is DE. So you will help me with this because it's quite similar to the earlier one. Yeah, tell me the triangles we'll have to consider, children. In triangle.
BAE.
Yeah, BAE and okay, so BAE is that big triangle and then the smaller one?
E, ma'am.
Again?
CDE.
CDE or DCE. BAE, DCE. Yeah. Yeah, first. Common angle?
Angle B, ma'am. Angle E, ma'am. DEC.
No, I think I've written the bigger triangle first. So in the bigger triangle, it is angle BEA, right? Angle
Yes.
BEA in the big triangle is equal to angle DEC in the small triangle. Okay, common angle. And then we have parallel lines. So corresponding angles are equal. Yeah. Okay, so I think I'll do it. You all know this well. So angle BAE is equal to angle DCE. BAE is equal to DCE. Corresponding angles are equal. Corresponding angles are equal. Okay, so sometimes, we have a doubt as to when to use similarity, when to use BPT. See, if it is about, if you have a figure in which information is given about these two sides and you're asked to find something related to these two sides, you can use BPT or similar triangles. See, BPT, involves only two sides of the triangle. Similarity connects all the three sides of the triangles. When we use BPT, the ratio you get will be this one upon this one is equal to this one upon this one. So it has the line segments of only these two sides of the triangle, BPT. The line segments in the proportion, when you use BPT, will be only from these two sides. So if the information given in the question, as well as what you have to find, is all about something here or here, then BPT is sufficient. You can even use similar triangles. But if it has got to do something with this and this, if information is given about these portions, or you have to find something of these, then you have to use similar triangles because BPT does not connect these two line segments. While similar triangles does. You get a ratio of these two sides also. Yeah. So here you can see that, X and 6 are marked here. Where is X? This is X. This is X. And we have 6 here. So when information is given about these line segments, it's better you use similarity. So similarity is broader than BPT. So where you have to use BPT, even if you use similar triangles, you'll get it. Supposing you have to use BPT, but you use similar triangles, it's still fine. But if you have to use similar triangles, but you use BPT, you may not get it. You may not get it. In BPT, we have only 2 ratios. Similarity, we have 3 ratios. So the similarity is broader than BPT. If you have to use BPT in one case, but you use similar triangles, you can get the result. But where you have to use similar triangles, you'll have to use that only. With BPT, you may not get it. Okay, so here we have X and 6. We have X marked for CD and 6 for AB. So since we have information about these line segments, we'll use similar triangles. So therefore, triangle BAE is similar to triangle DCE, double A similarity. Now, once the triangles are similar, the corresponding sides are proportional. So we have BA by DC is equal to AE by CE is equal to BE by DE. Similar triangles corresponding sides are proportional. So BA, what's BA? 6 by DC X equals AE. AE, no, nothing is given. So let's just use some variables there. We'll just call this one A, this one B, right? Yeah. So AE is A plus B by CE. CE is B equals BE by DE. BE by DE. You can see we have information there, children. You can see that. BE, how much is BE?
4 plus y.
4 plus y. 4 plus y. And how much is DE?
Y, ma'am.
Y. So I think we can ignore this side then, because mostly two ratios are enough. So we'll take up the third one if needed. So I'll come back here. I'll come back to this. We'll not unnecessarily take up this ratio. See here. You see, that's why I write and then delete, because this is, we do as students also, we work and then we realize. So how do you know now if I tell you ignore this ratio? If I say ignore this ratio, then the question is why? So what I'm saying is, see, since we have information in these two ratios, three ratios are too much. 2 is enough to compare or to work with proportions, 2 are enough. 2 ratios in each proportion is sufficient mostly. 2 ratios in each proportion is enough actually. I'm saying each proportion because this is from the first set of triangles we have. Now we are going to take up another set of triangles, prove that they are similar and write the proportion. So in each of these proportions, it's enough if we have 2 ratios. Third one is mostly not needed. So if we need, we'll come back and, use A, B and write it again. Yeah, so I'm just crossing this. I'm just crossing this. And I'm just crossing that, and you can just write BA by DC is equal to BE by DE. That is, we are going ahead with only those 2 ratios. Okay, so I'm substituting here, children. Write all the 3. Since we have information about these 2, we'll go ahead only with these 2. If needed, we'll come back to A by C. For now, these 2 are enough. Yeah. Now BA 6 by DC X equals BE 4 plus Y by DE Y. Okay, so 1. Now in triangle, so this one, this big triangle, and inside that we have ACD. So in triangle AEF and triangle ACD, AEF, ACD. So angle, I've written the big triangle first, AEF, and then the small one, ACD. So in AEF, angle F or angle EAF is equal to angle EAF CAD, CAD, common angle. And then the corresponding angles, angle AEF in the big triangle is equal to angle ACD of the small triangle, corresponding angles. So therefore, triangle, if you call it AEF, the big one, similar to triangle ACD, the small one, double A. The big one, if you call it AEF, the small one is ACD, double A. Proportion AE by AC is equal to EF by CD is equal to AF by AD. Okay. Now AE not known, AC meaning not given. EF is what? 10. CD is X equals AF not known and AD not known. Yeah. So now we need to decide which ratio to go ahead with. Okay. So here we have only 10 by X children. So here we have only 10 by X. We have only one ratio, 10 by X. Now, listen to this. Yeah. Now, in this triangle, children, in this triangle, okay, in this triangle, we have when you use BPT in this triangle, children, when you use BPT in this triangle, you will get ED by DB. ED by DB, or because we're using similarity here, you can even do this. ED by EB is equal to EC by EA, right? So Y by, if this one is Y by Y plus 4, this one also will be Y by Y plus 4 using BPT. Using BPT, I'll tell you again. Here. Or we can find AE by AC. We can find AE by AC using this triangle and BPT. See, the thing is, in this proportion, we only know 10 by X. I think it was 10 by X. Yeah, 10 by X. We don't have values for the other two ratios. Okay, so now we have to think what to do. Now, when you have a look at these ratios, you find AE by AC here. Now, this AE by AC, see here, AE by AC is here in this line segment. So if you consider this triangle, children, in this triangle where this one is marked, this is 4 and this is Y. Okay, so using this and BPT, just highlighting the triangle. Okay. Yeah. So in triangle, remember we need to get AE by AC. Okay. So in triangle AEB, what's parallel? CD is parallel to AB. Therefore, by BPT we have, therefore by BPT. Now we'll just remember this. We need AE by AC, children. AE by AC. So let's write this proportion by BPT. Because you want AE by AC, we'll write by BPT. BE by, tell me, BE by, you want AE by AC, children. Okay, let me write that here. You want AE by AC. This is what you want. AE by AC. So what should you write?
BD, ma'am.
Yeah. You want to find AE by AC. So that side you should write BE by BD. BE by BD. We are trying to find AE by AC, children. We are trying to find this. So you can even write that first, AE by AC. Now, if you write AE by AC, you should write BE by BD. So what is BE by BD? BE is 4 plus Y or Y plus 4 by BD. BD is 4 is equal to, we don't know this, is equal to AE by AC. Now use this. Okay, so use this. Yeah. So we have AE by AC is equal, we are not going ahead with this. So AE by AC is equal to EF by CD. A by AC is 4 plus Y by 4 is equal to EF by CD. EF is 10 by CD. CD is X. CD is X. Yeah. So this one is 2. I'll just write this again. Yeah, AE by AC is 4 plus Y by 4 is equal to EF is 10 by CD is X. And call this 2. Call this 2. Yeah. Now how do we proceed, children?
By cross multiplying the equation.
Cross multiplying. Huh? What do we have in 1, children? Is there any ratio common in 1 and 2, children? Is there any ratio common to?
Ma'am, 6 by x is equal to 10 by x, ma'am.
No, but there's nothing common, right? See, okay, I'll just want to say one more thing. Okay, 1 second. I just want to say one more thing. 1 minute. Now, in 2 proportions, see, if we have a proportion like A by B is equal to C by D, and we have another proportion like E by F is equal to A by B. Now, if we have proportions like this, children, so in both the proportions, we have a common ratio A by B. So from 1 and 2, we have C by D is equal to E by F. When you have 2 proportions in which one ratio is common to both the proportions, this is what we conclude. Since A by B is common to both, C by D is equal to E by F. Now, but in our case, there's nothing common. We have something like A by B is equal to, here it is x plus y by x. And another one we have C by D is equal to x plus y by y. There's something similar, but we don't have the same thing. We don't have the same ratio, but we have something similar. Similar meaning something involving the same variables, same values, but we have nothing same. In such cases, you will have to, you may have to add the 2 proportions, subtract the 2 proportions, multiply the proportions, or divide the proportions. You can do anything. So this is how we handle proportions. When we have 2 proportions, I'll write this again. A by B is equal to x plus y. A by B is equal to x by y. C by D is equal to, say, x by y. So here, in these 2 proportions, x by y is common to both. So from 1 and 2, we can conclude that A by B is equal to C by D. So in proportion 1 and proportion 2, when ratio is common to both, in that case, the conclusion is A by B is equal to C by D. But in these proportions, let me call it 1 and 2 here. So in these proportions 1 and 2, nothing common, but we have something similar here, but nothing is common. This is A by B, this is C by D, this is x plus y by x, but this is x plus y by y. In such cases, you can add the proportions, add the 2 proportions, subtract the 2 proportions, multiply the 2 proportions, or divide the 2 proportions. Divide one by the other. I'm not saying any one of this will work. You should choose one of these, I'm saying. You must choose one of these. I'm not saying any one of this will work and will help us to get the answer. No, no, no. This is what you can do. These are the options available and you will have to choose the right one. Okay. So here, children, will add 1 and 2 because on adding, you will get the common denominator for this one and this one as 4 plus y. And the numerator also is 4 plus y. So we'll just work that. 6 by x, let me write it one below the other. 6 by x is equal to 4 plus y by y, 4 plus y by y. And 4 plus y by 4 is equal to 10 by x. All right. So what you can do, what you should do here is put the ratio, write this one as y by 4 plus y and write this one as 4 by 4 plus y. Then only the common denominator will be 4 plus y and in the numerator you will get y plus 4. So they get cancelled and you get 1 and you will get the result. Take apply invert endo, meaning take reciprocals on both the sides. Take reciprocals on both the sides. See, you should have, see, supposing you have x plus y by x and x plus y by y, and you want to add this. If you want to add this, if you add it like this, you will get xy is the common denominator. Xy is the common denominator. So what will you get in the numerator? X plus y plus x plus y. So you get 2x plus 2y, right? By xy. So you get 2 common and then by x. This is the result. See, I'm not saying this is wrong. This is the result. But which is not favorable for us now. The same thing if you handle it like this. Children, I just want to repeat this because I want this to reach everyone. I'm saying if you have x plus y by x and x plus y by y, supposing you have ratios like this and you want to add them. I'm showing you the two cases where you add it like this and where you take reciprocals and add, where you take reciprocals and add, children. Okay. So here, what's the result? Xy is the common denominator. So you get x plus y. Sorry, what do you get? I think I was wrong. Yeah, what do you get, children? You should multiply this by y, right? I think earlier I went wrong in calculating that. Yes, xy is a common denominator. What will you? So you should multiply this one with y, right? So it will be y into x plus y plus here x into x plus y. Common denominator is xy. You need to multiply here this numerator with y. So it will be y into x plus y plus here you need to multiply the numerator with x. So x into x plus y. So some blah blah blah, it goes on like this. Whereas when you take the reciprocals and add, x plus y is the common denominator. I'm not getting any response. And you get x plus y. Because common, the same thing, no, we have. So x plus y cancels and 1. No, I'll just pause for some time because I just want your confirmation before I go ahead. Just let me know if it's
understood.
okay. I'm just telling you why you should take reciprocals and add. When you add it as it is, you get a result. When you take reciprocals and add, you get a result. I'm not saying this is wrong, this is right. Both are correct, but which is favorable, I'm saying. We are talking about which is favorable for us or which will help us get the result faster without any complication is what we are talking about. Both the results are right. You can add it as it is. You can take reciprocals and add. Both are fine. But which is favorable for us? Which one will help us to get the result faster? We're going to choose that one over the other one. Yeah. So this one, I'm writing using invert endo. I'm taking reciprocal because I have 4 plus y here. I have y here. I have 4 plus y here and 4 here. I want that 4 plus y in the denominator. That will be more helpful. I want that 4 plus y in the denominator. That 4 plus 5, which is now in the numerator, we want that in the denominator. Okay. For that, we need to take reciprocals on both the sides. That is applying invertendo. Applying invertendo or taking reciprocals on both the sides. Okay. So applying, or you can just in simple language, taking reciprocals on both the sides. Taking reciprocals in one, we get x by 6 is equal to y by 4 plus y. And then taking reciprocals in 2, we get in 2 we get 4 by 4 plus y is equal to 10 by x. 10 by x or 10 by x is equal to 4 by 4 plus y. Now we'll add these two children. We'll add these two. You can call this 3. You can call this 4. Now add 3 and 4. 3 plus 4 gives x by 6 plus 10 by x is equal to 4 by 4 plus y plus 4 by, oh sorry, y. It's very unlikely that we get x in the denominator. Oh. Oh, I've not written it correctly here. I'm sorry. That's what I was wondering. 10 by x is x by 10, no? 10 by x is x by 10. I didn't write this correctly. Sorry, children. Yeah. Yeah, children. Now what's the common denominator? 6 and 30. Okay, so 6 5s are so 5x plus 3x is equal to 4 plus y common denominator. So you get y plus 4. So 8x by 30 is equal to 1. So x is equal to 8 by 30 will come to the other side as 30 by 8. Or you can cancel here and then take the reciprocal. So 2 4s are 2, 15 times. So on the other side, x is equal to 15 by 4. This is the value of x. So substitute and find the value of y. You have the proportion, so substitute and find the value of y. Yeah, before we find the value of y, this is understood, children? Why we take reciprocals? Sorry, yeah. No, like why we have to take reciprocals and then add. So when you do that, on one side, the result will be 1. So it simplifies the whole thing. So like this, we are able to find the value of x. We'll substitute and find the value of y. Since I don't have place, I'll just clear this and do this again. You all understand. I'll just use the term invertendo itself. Yes, now adding. LCM. LCM. So the numerator denominator both are the same, so they get cancelled. 2 4s are 215 times. So x is equal to 15 by 4. Now substitute x is equal to 15 by 4. In 1. You have x by 6. You can use this one. You can use this one here or the reciprocal, which one? Whichever. Both will give you the same result. Use this 6. So in 1 meaning 6 by x, 15 by 4. Yeah. In 1 or 2, anywhere you can substitute. So here 6 by x, 6 by x, 6 divided by x, 15 by 4 is equal to 4 plus y by y is equal to 4 plus y by y. We are trying to find the value of y. We don't know y. We're trying to find the value of y. We found x. So 6 into 4 by 15 is equal to 4 plus y by y. So what is this you get? 3 2s are 3, 5s are. So 8 by 5. 8 by 5 is equal to 4 plus y by y cross multiply. So 8y is equal to 20 plus 5y. So what is that you get? 3y is equal to 20. So y is equal to 20 by 3. Y is equal to 20 by 3. So the whole procedure is this. You need to take up two triangles like this. Prove that they're similar, write the proportion. Again, two triangles, similar, write the proportion. Mostly, in each proportion, 2 ratios are enough. We don't have to write all the 3 ratios. Sometimes we'll have to find the length of the missing sides. In that case, we may have to use all. Whenever we have to compare or use 2 proportions and proceed, 2 ratios are enough in each. Okay. So we get one like that by substituting, we get one like this. And to get this second one, remember we have to use BPT. We used BPT here. In this triangle, we used BPT in this triangle. Why we took up this triangle is because we know the segments of the side BE here. This one is marked 4 and this one is marked Y. We should not unnecessarily introduce variables. So in this triangle, since this line segment is parallel to this line segment, by BPT, we have AE by EC here. We have AE by EC here. Sorry, AE by AC. So that AE by AC can be found using BPT, which is BE by BD. Yeah. So to find AE by AC, So when you look at the figure, this is AE by AC here, AE by AC. So when you take up this triangle, this is parallel to this is given. So by BPT, you can find AE by AC. So you should write AE by AC is equal to BE by BD using BPT is equal to BE by BD. So BE is what? 4 plus Y by BD 4. So like that we get 4 plus Y by 4. Yeah. All right. Yeah. So like that, then compare the two proportions. So we have 1 and 2. Compare 1 and 2. So I told you when you have proportions, you can, if one ratio is the same in both the proportions, you can, by comparing those two proportions, you get a new proportion. I showed you that. If you have A by B is equal to C by D and C by D is equal to E by F. In these two proportions, C by D is common. So the new result is A by B is equal to E by F. So this we do when in the two proportions we have a ratio common. If there's nothing common, if there is nothing common, when you have two ratios and nothing is common, then you can add the ratios, add these two ratios, subtract these two ratios, multiply or divide the two ratios. So here we choose to add the two ratios. Sorry, we choose to add the two proportions, 1 and 2. But before we add, we need to take invertendo, apply invertendo and then add. Because we have 4 plus y by y and 4 plus y by 4. We wish to have it as y by 4 plus y and 4 by 4 plus y. So that there when we take the LCM, it becomes 1. So take invertendo, apply invertendo in 1 and 2, write the new results, then add them. That way you'll be able to find the value of x and substitute to find the value of y. Yeah, take a picture, children. Done?
Taken.
Okay. Done, children?
Yes, ma'am.
Okay. Okay. Look at this one. In an isosceles triangle ABC. In an isosceles triangle ABC, the base AB is produced both the ways. Oh, the base AB, is it? Okay, I'm sorry. The base AB. In an isosceles triangle ABC, the base AB. So the base AB is produced both the ways. It's produced both the ways to P and Q. The base AB is produced both the ways to P and Q. Such that AP into BQ, AP into BQ is equal to AC square. Prove that triangle APC. So where is APC? This is triangle APC. Triangle APC is similar to BCQ. Similar to BCQ. Okay. So this is an isosceles triangle. It's given it's an isosceles triangle. In an isosceles triangle, you know, the term base is not used for any of the equal sides. Base meaning it is not any of the equal sides. Okay, let me put it like this. If these two sides are equal, supposing these two sides are equal, then this one is the base. Base need not be the side on which the triangle stands. It looks like the triangle is on this one, no? So we normally feel this is the base. Correct. This is the base. I'm not saying it's not the base. But in an isosceles triangle, when you have to understand correctly which side is referred to as the base, remember that the equal sides are not called the base. So if these two sides are equal, then this is the base. If these two sides, sorry, 1 second. If these two sides are equal, then this one is the base. The base is not any of the two equal sides. It is the third side, which is not equal to any of the remaining sides. That one is the base. So in an isosceles triangle ABC, the base AB means AC is equal to BC. The base is AB. That means the remaining two sides, AC and BC, are equal. It's given the base is AB. That means the remaining two sides, AC and BC, they are only equal because base AB is referred to as the base. It's produced both the ways too. That's why we mark AC equal to BC. Though it's not given, it's not mentioned. The equal sides are not mentioned. It's an isosceles triangle. The equal sides are not mentioned, but because it is base AB, we get to understand that AC and BC are the equal sides. Okay. All right, children. So we are given that. So we know that AC is equal to BC, and we also have this this equation AP into BQ is equal to AC squared. All right. This is given. Now this means AP into BQ is equal to AC into AC, correct? Now we'll just make a proportion out of this. We'll make a proportion out of this. See, like if you have A into B is equal to C into D, you can make a proportion out of this. You can bring the C to this side. A by C is equal to, you can take the B to the other side. A by C is equal to D by B. You can also bring the D down. A by D is equal to C by B. That's the fact. Okay. So from this, we are going to make a proportion. So AP by AC, we have AC only on the other side. So AP by AC equals AC by BQ. Always remember, when you have an information of this sort, that is, you have product of line segments on the two sides. AP into BQ. Product of line segments. AP is a line segment. BQ, another line segment. AP into BQ, product of two line segments. On the other side, AC square, AC into AC. So again, product of the same two line segment. So when you have products like this on either sides, remember that you can make a proportion out of it. You can make a proportion out of it. So like this, we have AP by AC is equal to AC by BQ. Now, let's make this more, meaning let's give this more clarity. So let's mention the triangles like this. AP is of which triangle, children? AP of triangle, which triangle does AP belong to?
CAP.
Triangle?
CAP.
Yeah, see AP, correct. AP of triangle. But since here in the question we have APC, I'll just write APC so that just for that sake. AP of triangle APC by AC of triangle. Okay, now 1 minute. Before that, what do you understand? AP and AC both are of the same triangle, no? AP and AC, but they should be of different triangles. So what we'll do, AP by, we know that AB is equal to, we know that BC is equal to AC. We know that BC is equal to AC. So what we'll do, this AC, we'll replace with BC is equal to AC by BQ. Reason because AC is equal to BC. AC is equal to BC. That's the reason. See, when we try to write this here, children, AP of triangle APC by AC also, when I had a look, oh God, AC is also of the same triangle APC. But actually, we wanted a different triangle. So you can write AC as BC. AC as BC. Because AC is equal to BC. So now, yeah, now tell me, BC of triangle. BC of triangle.
BCQ.
BCQ is equal to AC of triangle.
APC.
APC divided by BQ of triangle.
BCQ.
BCQ. So we see that the sides are proportional. The two triangles here are APC and BCQ. APC, BCQ. The triangles which we have to prove are similar to each other. Okay, so we have the line segment. We have a proportion. We have a proportion made up of the sides of the two triangles which we have to prove are similar. We have a proportion AP by BC equal to AC by BQ. Now these line segments are sides of the two triangles which we have to prove are similar to one another. So when sides are proportional, we need to find that included angle. You need to find the angle included by AP and BC. Sorry, AP and AC of triangle APC and BC and BQ of triangle BCQ. So if you can find that and show that they are equal, then by SA similarity criterion, the two triangles are similar to each other. One triangle is APC. The sides of that triangle are AP and AC. AP and AC are the sides of the triangle APC. BC and BQ are the sides of the triangle BCQ. Now the angle included by AP and AC, AC is this angle. This is the angle included by the sides AP and AC of the triangle APC. The angle included by the sides BC and BQ of the triangle BCQ is BC and BQ. This one, this angle. If you can show that these two angles are equal, then by SAS similarity criterion, the two triangles are similar to each other. We got the proportion easily because that was given to us in the question itself. AP into BQ is equal to AC square. So from that we got the proportion easily. Now this proportion includes the sides of the two triangles which we have to prove are similar. So we have no choice but to use SAS. We have to use SAS here. So we'll have to show that the included angles of the two triangles are also equal. So that's what I've written here. These are the arms. These will be the arms of that triangle. I'm sorry. These will be the arms of that angle. AP and AC of triangle APC. BC and BQ of triangle BCQ. These two are the arms of that angle. AP and AC. AP and AC. So this is the included angle. Then this is the included angle. BC, BQ. BC, BQ. Then this is the included angle. Now we'll have to show that these two angles are equal. That's not given. That is not given. We'll have to show that these angles are equal. Okay. So for that, let's come back here. We'll mark this 1 and 2, this one 3 and 4. Right? You can stop here. You can just call this 1 and stop there. Now, we'll say angle 1 is equal to angle 2, given. Given or because AC is equal to BC. Because AC is equal to BC, the angles opposite to them are also equal. Isosceles triangle property. So if 1 is equal to 2, 180 minus angle 1 will be equal to 180 minus angle 2. Now 180 minus angle 1 is angle 3 equals 180 minus angle 2 is angle 4. So like this, you can show that angle 3 is equal to angle 4. Angle 1 is equal to angle 2 because ABC is an isosceles triangle with AC equal to BC. So in an isosceles triangle, when two sides are equal, the angles opposite to them are also equal. So 180 minus, if angle 1 is equal to angle 2, 180 minus angle 1 should be equal to 180 minus angle 2. You're doing the same thing on both the sides. So 180 minus angle 1 is angle 3. 180 minus angle 2 is angle 4. So like this, angle 3 is equal to angle 4. Call this result 2. So from 1 and 2, from 1 and 2 triangle. Now, the order, how do you, name the triangles? The order. So now, children, it is AP. You have mentioned about AP. You have mentioned about AP and AC. You have mentioned about AP and AC of one triangle. Now, what is common here? Which is that letter which is common here? A, right? A is common. So if you write PAAC, it is triangle PAC. And in the other triangle, we have mentioned about BC and BQ. BC and BQ. 1 minute. We are talking about the order in which we have to name the two triangles, children. In triangle APC, we have mentioned the sides AP and AC. Now, in these two sides, AP and AC, the letter A is common. So I'm writing this one as PA, AP as PA, PAAC. So as PAC. PAAC is triangle PAC. In the other triangle, we've written about BC and BQ. So B is common. So I'm writing this as CB. CB, BQ, CB, BQ. CBQ. The triangle is CBQ. CBQ. So from 1 and 2, triangle PAC. PAC is similar to triangle CBQ. See, just writing the order from the question is also fine, but I was just trying to tell you how you name it. Now this PAC, if you write it in the other way, APC, see AP, APC will be equal to BCQ. You change the order, APC, then it will be BCQ. You can write the order which is given here, children. APC, BCQ, can write it. I was just telling you how to write the order correctly. How to write the correct order from 1 and 2. Triangle PAC is similar to triangle CBQ or triangle APC is similar to triangle BCQ. So you've mentioned two sides of the triangle. So using that, you can name the triangle in the correct order. That's what I was talking about. Yeah. So, and also remember from an information like this, you can create a proportion. And that proportion will have the sides of some two triangles. So you should make out the angle included by the two sides in each triangle and prove that that angle is also equal. That is, that angle of one triangle is equal to the corresponding angle of the other triangle. Then by SAS, the triangles are similar. Yeah, you can ask me if you have any questions, children. Take a screenshot.
Taken, ma'am.
Yeah. Yeah, children, use the emoji. Raise your hand. Very good. Rajat, Madhumita, Danya, Florentina, Raja, Raghavi, Sashank, Navya, Rakshita, Ranjan, and Krishmi. Krishmi is there. All the children, yeah. Thank you. Yeah. Yeah, now I'll just pick a question similar to this. Yeah. Let's try this one. Yeah. So in the figure, prove that. Oh, this is different. Okay, fine. Let's do this first. Yeah, okay. Let's. No, I wanted to actually do this, children. I'll do this and come back to that one. 1 second. Sir. I wanted to do a question similar to what we just did. Yeah, children. So if AD square is equal to BD into CD, AD square, so we are given that AD square is equal to BD into CD. So that means AD into AD equals BD into CD. Now AD by BD. You can even bring CD down. Anything is equal to CD by AD. Now let's make it more clear. AD of triangle, children. AD of triangle.
ADB, ma'am.
Yeah, you can say ADB or ADC, anything. AD of triangle ADB or ADC because it's common to both. So AD of triangle ADB divided by BD. This one you should say of triangle
ADB.
ADB. Now, if you want to write the other triangle here, now since BD is also of the same triangle, you can make this one. You can make this one ADC. I'm not saying it's wrong. Otherwise, you should exchange these two sides. You must exchange these two sides. You should put the CD down and take the BD here. Have one triangle in the numerator, a different triangle in the denominator. That's what I'm trying to say. Have one triangle, the side of one triangle, any triangle in the numerator, and the denominator triangle should be a different triangle. So we'll have to change. So because BD is only of triangle ABD. So we'll just write the numerator as ADC. ADC. So AD belongs to both ADB and ADC. We wrote ADB, but the denominator BD is also of the same triangle. So we write AD of triangle ADC because we wish to have different triangles in the numerator and the denominator. By BD of triangle ABD. ADC, ADB, okay, ADB is equal to CD of triangle. CD of triangle ADC by AD of triangle. Yeah, ADB. So in the numerator we have ADC and in the denominator we have ADB. Numerator we have ADC, denominator ADB. So now when you take the triangle ADC, the two angles we have the two sides we have mentioned are AD and CD. And in triangle ADB, the two sides we have mentioned are BD and AD. So we have a proportion here. We have a proportion. We need to show that the included angles in the two triangles are equal. Then by SAS, you can show that the triangle is similar and then prove that BAC is 90 degrees. Yeah. So we need to find the included angle AD and CD. 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 Oh my God. Yeah, AD and CD. This one, children. This one. And then BD and AD. BD and AD. This one. Correct? See, writing something equal to something is not meaningful. You need to find the, the angle contained by these two sides. Once you get the proportion, there is triangle ADC, there is triangle ADB. The two sides of this triangle we have mentioned in the proportion. This triangle has three sides, but the two sides we have mentioned here in this proportion are AD and CD, AD and CD. And the angle contained by these two sides, AD and CD, AD and CD, is angle ADC, which is angle 1. Which is angle 1. And here, these two sides. Not these two sides, sorry. In this triangle, the two sides are BD and AD. BD and AD. And BD and AD, BD and AD, you can see contain this angle, which will mark as 2. And clearly, angle 1 is equal to angle 2. Angle 1 is equal to angle 2 is equal to 90 degrees. So you can call this result 1, this result 2. So from 1 and 2, from 1 and 2, the triangles are similar to each other because sides are proportional, included angle equal. Sides proportional, included angle equal. So SAS similarity criterion, the two triangles are similar to each other. Now, how do we name the triangles in the correct order? So take up the sides AD, CD. Of the triangle ADC, we have written AD and CD. Okay, now D is common. D is the letter which is common. So write this as DC. AD, DC, ADC. AD, DC, ADC. Of the triangle ADC, we have mentioned about AD and CD. You can see it. We have mentioned about AD and CD. The letter which is common is D. So write this as DC, AD, DC. So the name of the triangle is ADC. And in the other triangle, we have mentioned about BD and AD. BD and AD. Again, D is common. So we'll write this as DA, AD as DA. So it is BDA. BDA. This is the correct order. This is the correct order. Triangle ADC is similar to triangle BDA by SAS, similarity criterion. Yeah. Sides proportional, include angle equal. And this you name the triangles in the correct order. Now, look at the figure. Now we know that, see, the thing is we'll have to prove that this angle is 90 degrees, children. We'll have to prove that this is 90. So I shouldn't say smart work, but you need to like think differently here. So now to prove that this one is 90 degrees, we'll take up some other two angles which add up to 90. So let me mark this angle 3 and this angle 4. Okay, let me mark all the angles because see in the exam, how do you know that you should mark only these two angles? So for that sake, I'm marking all the angles, children. You don't have to mark actually all. Maybe you can mark with a pencil and then erase what you're not using. You can mark with a pencil and erase the angles which are not using, which are not needed. So like this, I've marked all the angles possible. Now I'll write angle 3 plus angle 4 is 90. Am I right? Angle 3 plus 4 is 90. Is this correct, children?
Yes, ma'am.
Yes, ma'am.
Okay. But I want to get 4 plus 5 is equal to 90. This result, angle 3 plus 4 is equal to 90 is true. But I don't want this result. I want 4 plus 5 is 90. The intended or the result which the desired result is angle 4 plus angle 5 is 90. This means angle BAC is 90. So we want 4 plus 5 90, but we have 3 plus 4 90. That means you should show that angle 3 is equal to angle 5. If you show that angle 3 is equal to angle 5, you can replace this 3 with 5 and you will get 4 plus 5 is 90, which means angle BAC is 90. We can do this in another way also. We'll understand this one first. So we write angle 3 plus angle 4 is equal to 90. But angle 3 is equal to angle 5 because in similar triangles, corresponding angles are equal. Corresponding angles are equal. In similar triangles, corresponding angles are equal. See, compare angle A is equal to angle B. D is not common. D is 90 in both the triangles and C is equal to A. So look at this, children. In this triangle ADC, let me just draw it here because it's getting very crowded, the triangle. Let's mark off the equal angles, children. ADC in this triangle, see it. ADC, BDA. Okay. So the corresponding vertices we can make out from this order. ADC, BDA. So ADC is this triangle. BDA is this triangle. Now let's start. In ADC, angle A. See, I'm reading from this one, children. I'm reading from this. This is the correct order. This is the correct order. This is the order in which the vertices not coincide. The vertices are related. So I'm reading from this one. Angle A is angle A of this triangle ADC. This is A of ADC is equal to B of BDA is equal to B of BDA. These two angles are equal. That's what angle 3 is equal to angle 5. Let's write the other results also, children. 1 second. We'll write the other results also. Then look at this one. D of ADC, which is D of ADC. This one is D of ADC is equal to D of BDA. This is BDA. This is D of BDA. Yeah, then 90 each. Yeah, that we already know. Okay, what we don't know? C of ADC. C of ADC meaning C of the triangle ADC. So ADC is this triangle. Angle C of ADC is equal to A of BDA. BDA is this triangle. This is BDA. A of BDA is this one. So here we go, children. These are the corresponding angles of the two triangles. We have proved that the triangles are similar, right? So you can see the equal angles. 90 degrees, we already know. Apart from that, you can see the equal angles in the two triangles. The two triangles are similar, so their corresponding angles are equal. So these angles are equal. That's why we have angle 3 is equal to angle 5. Angle 3 is equal to angle 5. Because in similar triangles, corresponding angles are equal. So this implies now instead of writing 3 plus 4, 90, 3 is equal to 5. No? So angle 5 plus 4 is equal to 90. 5 plus 4 is equal to 90. Now what is 5 plus 4? That's nothing but angle BAC. BAC is equal to 90. You can do it like this. Or children. You can write angle 5 plus, see, we wrote angle 3 plus 4 is 90, right? Instead of that, you can also write angle 5 plus 6 is equal to 90. Angle 5 plus angle, see, you cannot write angle 4 plus 5 is 90. That we don't know. That only we have to prove. Angle 4 plus angle 5 is 90. We have to prove. That is not known. We can either write 3 plus 4 is 90. Angle 3 plus angle 4 is 90. Because, yeah, for obvious reason, it's a right triangle. So the sum of the acute angles is 90 degrees. You can write angle 3 plus angle 4 is 90. Or you can write angle 5 plus angle 6 is 90 in the other right triangle. So you can also do it like this. Or, so we've already proved the result. This is the other way, alternate method. So or angle 5 plus angle 6 is equal to 90. Okay. But we don't want this result. 5 plus 6 is 90 is fine. But we want 4 plus 5 is 90. We want 4 plus 5 is 90. That means you should show that 4 is equal to 6. 4 is equal to 6. But angle 4 is equal to angle 6. See here? Angle 4 is equal to angle 6. These two angles are equal. Angle 4 is equal to angle 6 because in similar triangles, corresponding angles are equal. So this implies 5 plus 6 is 90, but 6 is equal to 4. So this implies angle 5 plus 4 is equal to 90. Now what is 5 plus 4? Angle BAC. Therefore, BAC is equal to 90 degrees. Is this understood, children?
Yes, ma'am.
Yeah. Now see
Yes.
if this, the corresponding angles which I was telling you, angle 3 is equal to 5. You need to understand that clearly. Otherwise, I can repeat it, children. Anybody has a doubt there, I can repeat that. Naming the triangles in the correct order is very important. Only then you can match the corresponding vertices. Take a screenshot, children. Taken.
Taken, ma'am.
Yeah. Okay. Yeah. So here in this figure, you will have to prove that it's a converse of this question. Look at this question. In this figure, angle ACB is given to be 90. That vertical angle ACB is given to be 90. It's marked 90. And you will have to prove that CD square is equal to BD into AD. While here, we are given this equation AD square is equal to BD into CD. And we'll have to prove that the vertical angle is 90 degrees. BAC is 90. Here we are given an information of this sort, and we're asked to prove the vertical angle. The vertical angle is a right angle. While here, we are given that the vertical angle is a right angle, and we have to prove this result. Okay. So this one is simple. Like if you have to get a result like this, this is nothing but a proportion written in this form. There's nothing but a proportion. See, like if you have A by D is equal to D by B, when you cross multiply this proportion, you will get D square is equal to AB. See, you can see that this information, not this information, we'll have to prove this one, right? So, okay. So we can see that this equation is made up of 4 line segments. There's nothing but CD into CD is equal to BD into AD. This equation is made up of 4 line segments, CD, CD, BD, AD. So to get this result or to prove this result, you just have to show that 2 triangles are similar, and in similar triangles, corresponding sides are proportional. Write the proportion, cross multiply, and you will get this result. That's all. So when you see something like this, remember it's nothing but a proportion cross multiplied and written like this. A proportion cross multiplied looks like this. Okay. So we simply have to write a proportion in similar triangles and cross multiply it, and you'll get this result. And one more thing is, the proportion has CD square in it. Please listen to this carefully. This is important. The result has CD square in it. If you need to get CD square in your result, you need to show, you cannot show any 2 triangles are similar. You will have to show 2 triangles are similar, which have CD as a common side. Only then in your proportion, you will get CD 2 times. And when you cross multiply, you will get CD square. See, here you can do 3 things, You can prove that this small triangle is similar to the whole triangle. Or you can prove that this triangle is similar to the whole triangle. Or you can prove that this triangle is similar to this triangle. These are the 3 things you can do. Now, which one of these 3 should you do to get this result exactly? CD square is equal to BD into AD. So to get this result, you will have to choose those 2 triangles which have CD as a common side. So then it is triangle CDA, which has CD, and CDB, which has CD. In triangle CDA and CDB, you should prove that these 2 triangles are similar. Only then you will get only then you will get a proportion with the help of which you can get this result. CD square. So take up 2 triangles which have CD as a common side. So in triangle ADC and triangle BDC. So these two triangles have both of them have CD or DC in it. In these two triangles. Now this one also, children, is very, very important. Very important in a situation like this. So in this figure, you see a right triangle. See, what is this figure actually? There is a right triangle. There's a right triangle. And from the vertex containing the right angle, the altitude is dropped on the hypotenuse. Actually, this theorem is now deleted. So this is if an altitude, if a perpendicular is dropped from the vertex containing the right angle in a right triangle, then the two triangles on either sides of the perpendicular are similar to each other and to the whole triangle. This theorem is removed from your syllabus. Right triangle, perpendicular dropped from the vertex containing the right angle to the hypotenuse. Now these two triangles, so you have to prove, because we don't have the theorem, we'll have to prove. So you can prove that this triangle is similar to this triangle. You can also prove that this triangle is similar to the whole triangle. And you can prove that this triangle is similar to the whole triangle. Okay. Yeah. Okay. So in ADC, angle 1 is equal to in BDC, angle 2, 90 degrees. Okay. Then this is what I'm going to say now is very important, and it's used in most places where the figure looks like this. Okay. So now angle 3 plus angle 4 is equal to 90. I'm going to write out all those equations where we get equal to 90. Write all the equations where we get equal to 90. So angle 3 plus angle 4 is 90. And then angle 4 plus angle 5 is 90 because the vertical angle is a right angle. And also angle 5 plus angle 6 is 90. Yes or no, children?
Yes, ma'am.
3 plus 4 is 90 because angle 1 is 90. So the sum of the remaining two angles will be 90. 4 plus 5 is 90 because it's there 90 degrees. And then 5 plus 6 is also 90. This is enough. You can write one. Even 3 plus 6 is 90. 3 plus 6, angle 3 plus angle 6 is also 90. We'll keep this enough. Actually, okay, the minimum thing which you have to write, the minimum thing which is needed for comparison is you should write angle 4 plus 5 is 90. This is only used for comparing. 4 plus 5 is 90 because 4 is of one triangle, 5 is of the other triangle. You should write this. Then you must write any, so you should write this one. Then you can write this one or this one. Let me write it this way so that I can explain better. See, you have to write angle 4 plus 5 is 90, children. Angle 4 plus angle 5 is 90, you should write. Because angle 4 is of one triangle, angle 5 is of the other triangle. Okay, just write it 2 times. Now, along with this 4 plus 5 is 90, you can either write angle 3 plus 4 is 90, or you can write angle 5 plus 6 is 90. You can see that 3 and 4. 3 plus 4 is equal to 90. 3 and 4 are of one triangle, are of the same triangle. And when you write 5 plus 6 is equal to 90, 5 and 6 are of the same triangle. You must write this 4 plus 5 is 90. And then you can write along with 4 plus 5 is 90, you can write this or you can write this. Right? Any one of these two. Okay, so when you compare these two, 4 plus 5 is 90, 3 plus 4 is 90. So when you compare these two, we have angle 4 plus angle 5 is equal to angle 3 plus angle 4. So 4 on either side gets cancelled. Angle 3 is equal to angle 5. You can work all the three. Then you will say AAA similarity criterion. You can work all the three, say AAA. If you work any one of the two, then it will be AA. So here 4 plus 5 is 90, 5 plus 6 is 90. So that means 4 plus 5 is equal to 5 plus 6. So 5 gets cancelled on both the sides and angle 4 is equal to angle 6. So now in the two triangles, yeah, angle 1 is equal to angle 2. Angle 3 is equal to angle 5. 3 of one triangle is equal to 5 of the other triangle. 4 of one triangle is equal to 6 of the other triangle. So by AAA similarity criterion, the two triangles are similar to each other. So write this one. You have to write this one because angle 4 is of one triangle, 5 is of the other triangle. So this one is only used for comparing. So you must write that 4 plus 5 is 90, you should write. Then you can either write 3 plus 4 is 90 or write 5 plus 6 is 90. So if you write this one, you can show that 4 is equal to 6. If you write this, you can show 3 is equal to 5. So this is 3. You can or have written, but if supposing you write this, then this will be 3. If you write 2, then say AA. If you write all the 3, AAA. So therefore, triangle. Writing the order now is easy because you can just smash the angles and write. If I write if I write DAC, similar to triangle. Now D is D only in both the triangles. D is D in both the triangles. If you write A, which is angle 3, then angle 3 is equal to 5. So you must write C here. Then the third vertex B. AA or AAA similarity criterion. The two triangles are similar to each other. Now write the proportion. DA by DC is equal to AC by CB equals DC by DB. So now you have to write the first and the last one. So DA by DC is equal to DC by DB. Cross multiply, you will get DC square is equal to DA into DB. Now just write it as it is given in the question. DC square is CD square equals DB is BD into DA is AD. Hence proof. Okay, Ritika, I just saw your message that you're along with Raghavi in the class. Okay.
Yes, ma'am.
Okay. Yeah, Chetan. So this idea will be used extensively in this chapter, similar triangles. We'll take up more like this in the next session. So please keep this idea in mind. Any questions here?
No doubts, ma'am.
Okay. Taken a picture, children? Yes?
Yes, ma'am.
Okay, ma'am.
All right, yeah. We'll just do one, question using this idea. And then we'll wind up the session for today. Please don't leave the meeting immediately. I need to ask you something. We'll just discuss that and then you can leave the call. Yeah. So this one. Yeah. So nothing, children. So here, we'll have to prove that this triangle is similar to this triangle. This triangle is similar to this triangle. And then this triangle is similar to this triangle. Okay, let me number it and okay, let me number the triangles 1, 2, and 3. We need to prove that triangle 1 is similar to triangle 2. Triangle 1 is similar to triangle 3. And triangle 2 is similar to triangle 3. 1 similar to 2, 1 similar to 3, 2 similar to 3. And then the fourth one, we have to prove a different result. Okay. So I'm just numbering, like all angles possible. I told you in the exam, you will be drawing the figure in your paper. You mark off the angles with a pencil and erase the ones which you don't use. And then you can write the ones which are marked with a pencil with a pen. Yeah. Okay, I'll leave this angle. This one is 9 if needed. All right. So now in triangle AGF, and triangle GBD, we'll have to prove that these two triangles are similar. The top triangle AGF and on the left side GBD. Here you can name it in any order, children. We have just named the two triangles. Only when you use a similarity symbol, the order in which you name the triangles is important. Here it's fine. AGF and GBD. Okay. So in the two triangles, in the top triangle, angle 9 is 90. This one, children, I've marked this 9. In the top triangle, this is angle 9. This one, no, is 9. Okay. In that triangle, angle 9 is 90. And in the triangle on the left side, GBD, angle 5 is 90. Angle 5 is 90 because it's given that GFED is a square. It's given that GFED is a square. It's not written correctly. I've not typed it correctly here. I should correct this. What is given here? Oh, yeah, it's correct. DE, I'm not able to read it clearly. It's very small for me. DEFG, yeah. So DEFG, children. DEFG is given to be a square. This one is a square. Okay, so you all understand? Angle 9 is 90 is marked and angle 5 is 90 because this is 90. because this is 90. Angle 5 is also 90. Next. See, here is, I just want to, say this in detail. Now, you have to write one angle of the top triangle and another angle of the left triangle. That is one angle of this triangle and one angle of this triangle. The sum of which is 90. Tell me that. Tell me an information like this. Pick an angle of the first triangle, pick an angle of the second triangle, but their sum should be 90. Okay, you say some other information, children, then. How do we prove that they are similar? I want one more point. 9, 5, 90 degrees. One more.
Ma'am, GF is equal to GD.
GF is equal to?
GD, ma'am.
No. So we are trying to prove that the triangles are similar, not congruent. So equality of sides will not be helpful here. Two sides equal is not a valid information here. Sides must be proportional. Angles must be equal. GF is equal to GD will not be helpful here because we are trying to show that the two triangles are similar, not congruent. So when it's congruent,
angle G is equal to angle G.
Angle 1 equal.
Angle 1 is equal to?
Angle 3.
Angle 1 is equal to angle 3. Why?
Ma'am, since DGEF is a square, GF is parallel to DE. So corresponding
GF is parallel
angles.
to BC. Correct. GF is parallel to BC, which is the transversal?
GD.
GD is the transversal?
AB, sorry, AB.
AB is a transversal. AB is a transversal. Corresponding angles are equal. Corresponding angles are equal. So this makes double A similarity. Therefore, triangle. If you say AGF similar to triangle, A is 90 degrees. So in the other triangle, D is 90 degrees. Then G is angle 1 and angle 1 is equal to angle 3. So if you say G in the first triangle, you must say B in the second triangle. So DBG. DBG by double A similarity criteria. Angle 9 is 90. In the first triangle, angle 9 is 90 degrees. In the second triangle, angle 5 is 90 degrees. Then since we have DEFG to be a square, opposite sides are parallel. So GF is parallel to DE. And DE is a part of BC. So if GF is parallel to DE, then GF is also parallel to BC because DE is a part of BC. The extension of DE is BC. The extension of DE is BC. So if GF is parallel to DE, GF is also parallel to BC. So GF is parallel to BC and AB is a transversal. Angle 1 is equal to angle 3. We don't know the measure, but they're equal. We don't want the measure also. They're equal. Angle 1 is equal to angle 3. Corresponding angles are equal. So doubly similarity, the triangles are similar. Name the triangles in the correct order. AGF. A is 90 degrees. So you must write D in the second triangle. G is angle 1. In the first triangle, G is angle 1. A is 90 degrees. So in the second triangle, D is 90 degrees. If you say G here, G is angle 1. Angle 1 is equal to angle 3. So that is B here. Then the third vertex, F, D, B, G. Doubly similarity criteria. So AGF, DBG. The second one also will go somewhat like this. Tell me. In triangle AGF and triangle FEC. AGF, FEC. Angle 9 is 90 degrees in AGF and angle 6 is 90 degrees in FEC. 6 is 90 because this one is 90. This is 90. And then angle 2 of the top triangle is equal to angle 8 of the bottom triangle, FEC. Angle 2 is equal to angle 8 because GF is parallel to BC and AC is the transversal. AC is the transversal. Corresponding angles are equal. So therefore, triangle A is 90 degrees, A 90, E 90. Then angle 2 is F here and 2 is equal to 8. So it is C. Then the third vertex, AFG, EC, F, W. So, but it's in the question, it's given AGF. So there's nothing but AGF is similar to, if you write AGF, you should write EFC. Or AGF is similar to EFC. In triangle DBG and triangle EFC, DBG, EFC. Yeah. So in these two triangles, if you have to, supposing you don't have, any direct equal angles, then you have to use this method. That is, write an equality where one angle of the first triangle plus one angle of the second triangle is equal to 90. So you can write angle 3. See, we are talking about these two triangles, children. DBG, this one, we are talking about this triangle and this triangle. DBG on the left side and EFC on the right side. We're trying to show that these two triangles are similar. So directly we have angle 5 is equal to angle 6, 90. Angle 5 of this triangle is equal to angle 6 of this triangle, 90. If you don't have any direct information, this is what you should do. Because we have right triangles here. Write one angle of the first triangle and one angle of the second triangle. But there some should be 90. So I'm writing 3 of the left triangle plus 8 of the right triangle is equal to 90. Is equal to 90. Because in the whole triangle ABC, this is 90, no? This one is 3 and this one is 8. Look at the whole triangle ABC. In the whole triangle ABC, this is a right angle. Angle A is equal to 90 degrees. So angle 3 plus 8 will be 90. 3 plus 8 is 90. So write one information like this. Write one like this. One angle of one triangle, another angle of the second triangle, their sum is 90. Write this one. Now you should write, now you must write something like this. Angle 3 plus angle 4 is 90. That is the sum of two angles of the same triangle is 90. Or you should write something like this. 7 plus 8 is equal to 90, where two angles of the same triangle is 90. Now you can compare this with this and this with this. So this idea is what I said, remember. Remember this. So you should write angle 3 plus angle. Second. Yeah, you must write 3 plus 8 is equal to 90. Okay, 3 plus 8 is equal to 90. You must write. Then sum of two angles of the same triangle 90. So angle 3 plus angle 4 90. Or you can write angle 7 plus angle 8 90. Yeah, now when you compare these two, you will get angle 3 plus angle 8 is equal to angle 3 plus angle 4. 3 cancel, so you have angle 8 is equal to angle 4. Here when you compare, you get angle 3 plus angle 8 is equal to angle 7 plus angle 8. So 8 gets cancelled on both the sides. Angle 3 is equal to angle 7. You can always write angle 5 is equal to angle 6. Angle 5 is equal to angle 6. So AAA similarity criterion, or you can write 5 is equal to 6 and one of these two results. Any one of these two results you can write. I've just written both for practice children so that I can explain it, many times. So I've written both. So then the other thing is, this is 1, this is 2, and the third thing is angle 5 is equal to angle 6 is equal to 90 degrees. Therefore, yeah. So the order will be, if you say GBD, triangle GBD is similar to triangle. So G is what? Angle 4. GBD, you're writing 435. GBD, 435. So 435, 4 is equal to 8. 3 is equal to 7. And 5 is equal to 6. So if you write 435, you must write 876. 876. So CFE. CFE by AA similarity criterion or AAA, because we've written all the three. So GBD, but in the question it's given DBG. So DBG is similar to triangle EFC. AAA. Now the final result, the last one. DE square is equal to BD into EC. BD into EC. So you can see BD we have here, EC also we have here. We have BD and EC here. So let's write the proportion. In these two similar triangles, corresponding sides are proportional. So to get the last result in 4, we'll use this one. Triangle DBG is similar to triangle EFC. Proportion DB by EF is equal to BG by FC is equal to DG by EC, because in similar triangles, corresponding sides are proportional. Now look at the result we have. DE square, this is the result. We need to prove DE square is equal to BD into BD into EC. BD into EC. Okay, where is BD? BD is here. EC is here. And then DE. DE we don't have at all. But we understand that we have to take these two ratios. This is the result we need. This is the result we need. And in this result, we have BD, EC. So BD is here. EC is here. And apart from that, we have DE, but D is nowhere here. But anyways, we understand that we can ignore this proportion. Ignore this proportion. Okay, so we are going ahead with DB by EF is equal to DG by EC. All right, now cross multiply. When you cross multiply, you get DG into EF is equal to DB or BD into EC. Now, but there we have DE square. DE square. So we know that DG and EF, DG and EF, look at the figure, DG and EF. They're the sides of the square. And in the result, we have DE, which is also a side of the square. So you can write, so we have these two line segments, but in the result, we have only DE. But we know that DG is equal to DE and EF is also equal to DE. We got this BD and EC we got. On the other side, we got BD and EC. But here we have DG into EF, which is in the question DE squared. But all these three, DE, DG, EF, they're all the sides of the square. So you can replace, you can substitute DG and EF with DE. With DE is equal to BD into EC. So we have DE square is equal to BD into EC. Yeah, take a screenshot, children. Done?
Yes, ma'am.
You are done, children?
Yes, ma'am.
Yes, ma'am. Okay.